Hello, Doctor. I'm Dinesh Ravindran here, and my metric number is C190010. And we are from Group 15. And today I'm going to explain about our group project. So, first of all, I'm going to explain about the introduction. The LMC, which is Little Man Computer, is a computer simulator that simulated today's computer capability. It has one Newman architecture which contain an arithmetic logic units and register in the central processing unit, and instruction register and program counter in the control unit, input and output method, and data and instruction memory in the control unit in control unit. In 1965, Dr. Stuart Madnick created the Little Man computer as the educational computer model. It was often used to instruct children because it simulates a simple one human architecture computer that incorporate all of the core features of the modern computer. The LMC model center of a little character who is stuck in a locked mail room had one end of the room. There was under 100 mailbox memory number 0 to 99, each capable of carrying a 3-digit instruction or data ranging 000 to 999. The inbox and outbox mailbox, on the other hand, are used to receive the transfer data, respectively. A work area in the center of the room house the accumulator, rudimentary two function, addition and subtraction calculator, and the program counter, resettable counter. The program counter stores the address of the next instruction that the little man will execute. After each instruction, the little man's program counter is normally increment by 1, uh, allowing him to follow a program step by step, uh, iterations, a loop, and condition programming structure can be included in a program using branch instruction. If a certain condition is satisfied, the program counter will be set to a non-sequence memory location. In the one Newman architecture, every mailbox may carry either an instruction or data. The little man will try to interpret a memory location containing data as an instruction if the program counter reaches it. It is possible to build self-modifying code by inserting instruction into the mailbox that are meant to the read as code. The user then direct the little man to start execution. The instruction at memory position 0 after filling the mailbox with data. Turning off the computer by resetting the counter to 0, the program is effectively restarted, although it is a different condition. So we have derived a equation by our own and give it to our lecturer, so that we have to simulate that equation. We have simulate that equation in our LMC computer simulator and obtain the equation properly.
Assalamualaikum warahmatullahi wabarakatuh. My name is Uzay Sumbro with metric number AE190001. Okay, I will explain about the from section 3 for computer architecture organization. Okay, I will explain about the process or the step occurred in the execution of the program of LMC, which is Little Man Computer. Okay, as we know, the coding process is derived from the according to the Bot-Mass rule, and which our equation is a plus b times with the c square divided by d, and minus with the bracket e divided by f. So here is the assembly code where the codes are done in proper way and executed. And because of the BODMAS rule, so the condition is that we execute the c square divided by d first, then time with b, and plus with the a, and later on we minus with the, and we divide this e divided by f, and later we minus the value of it. So as follows: c d b a e and f. So the input of the value also will be in this condition, where the first input will be c, second is d, third is b, fourth is a, fifth is e, and sixth is the f, the input value. So this the step 1 of the squaring number of the c. This the what's it, the condition of the code, the assembly code that is done. Okay, because this code is used the square number, and the square number is as like if c square, so we take the value of 7 and we square with it, we get 49, and enter the input into the c. After the STA99, it is store the answer of the c square in the R99, the register 99. Okay, second step is the division, which is the division c square divided by d. So here is the assembly code, where the assembly code which is done from it. So from this value, where we input the d value and load the R99, so that we take the 49 value and divide it by 7, where it is minus with 7 by looping. So it minus 7 until it is executed with the last answer, which is 7. So subtracting the divisor, -7, and this it is stored in R90 register 98. For the third step is multiplication. This is the code of the assembly code of multiplication, and the we enter the p value because we want to times with the p, and we load into R98 data. So like we get the 7, the value of 7 at here. So and we times with the 6 is the input value of b, so we get 42. And the condition is like 7 plus 7 plus 7 plus 7 plus 7, we get 42. So with the add of loop, we keep adding the first number as many as second number of times, so we get until 42. Then the fourth process is the addition, which is the addition of the a with the a, and the first we input the data, the value of a, where our value of a is 5, and after we plus it, which is 42 plus 5, we get 47 in the output data. So on the fifth step, which is the division, this division is conducting for the e and f. So for this e and f assembly code, input is e value and input b is f value. So and so for example, which is e, we input the value of 9 and the f value is 3. So 9 is divisor by negative by 3 until the last value is executed, which is 3. So until the answer becomes 0 in the loop. So in the meantime, variable must be included in same loop such way that value goes up by 1. So the answer is stored in the 95, register 95. So for the last part, which is the subtraction of the previous register with the R95, so that we can get the answer for the last execution, which is 47 minus 3 is 44. Okay, and this is the process of the assembly code, which is done by my friend Jackie. Okay, for another part where we also can use the input data, we can change the ABCDEF data. So such as like a equals to 5, b equals to 11, c equals to 12, d equals to 8, e equals to 10, and f equals to 2. So we will get 190n. Similarly, we change again the data also, 8, 6, 9, 3, 7, and 11 for a, b, c, d, e, and f. So later on we will get 163 after execution. So if we use this LMC also using the manual calculation, we will get the same value. but also using the BODMAS also rule. So that's all for me. Thank you.
My name is Jackie Ho and my number commentary is D10033. Okay, this is our equations. A plus C squared divided with D times B and minus E over F. Okay, I move the C squared divided with D times B and plus A minus E divided with F. But don't worry, this two is same. Final answer we get the same. Example like this, 7 squared divided with 7, we get a 7 times the 6. For this 42 with plus 5, we get a 47. Okay, 9 divided with 3, so get the 3. So 47 minus 3, we get a 44. Okay. Next, I will explain. I will show the assembling language code. Okay, this first code is code of the squaring the numbers. So squaring our c square, c square. Okay, input is c, c stored in the s and log s. Okay, finally we get the answers c square. We store the answer in the R99. Okay, next code is code of divisions. Division, c squared divided with our d. Okay, input n is our d and store in n. N is our data variable. Okay, log the 99. Okay, log the 99. 99 is our answer of the c square. Okay, we use this code. We calculate the c squared divided with d. After we get an answer, we store the answer in the R98. Okay, next code is code of multiplications. So our input, this input we enter input B. So we enter input B. Okay, this code will help us to multiply the answer of the c squared divided with d times the input B. After we get the answer c squared divided with d and times the b, we store the answer in the R97. Okay, next is plus a. Okay, input a stored in 98. Okay, log the 97. 97 is our answer of the c squared divided with d times b. Okay, we log the R97 data with plus our input a plus R98 because we store the input a store in 98. After we get the answer, we store in the R96 and we can see the output. Okay, and the next code is the code of division. This division is for our e divided with f. Okay, input a store in a. Input a is our e value. We enter the input value e, and the input b is our input f. We just enter the f values. After we use this code for the e divided with the f. After that, this is our last course for the code of the substrate. Okay, we load the 96. Load the 96. 96. Okay, 96. Okay, we can see here 96. 96. We store the data. The data is the answer of the c squared divided with d times b plus the a. Answer, okay, R96. We know the R96 is our answer of the c squared divided with d times b plus the a. Okay, we minus R95. R95 is the answer of the e divided with f. So after that we get the answer, we store the answer in our R94. Okay, the DAT, we can see the AD second and SY1 answer. That is our data variable. We can see the one, that means is 1. and answer the value is 0. I will do the simulations of our assembling language code in a little main computer. Okay, first we type the code in here and we submit and we run, and the option we select the default fast. Okay, the code is depend this equation c squared divided by d times b plus a minus e over f. Okay, first c value is 7, d is 7, b is 6, a is 5, 9, 3, f is 3. After we will get the answer 44. Okay, so first we try c squared. 7 squared is 49. Okay, we can see our answer 49. After that we divide d. Our d is 7. 49 divided with 7, we get 7. After that, okay, we tie our b is 6, so we tie 6. 6 is 42. No, 7 times 6 is 42. 7 times 6 is 44 and 42, and plus our a is 5 plus 5. 42 plus 5 is 47. Okay, now we try 9 divided with 3. So 9 divided with 3, we get a 3. 47 minus 3, we get a 44. And our answer of these equations is 44. Compare here. Okay, we get a 44. And we store the data, the answer in R94, 44. Okay. R95 is E divided with F. R96 is our C squared divided with D and times B and plus A. And R97, okay, R97 is C squared divided with D times B, so 42. Okay,